Hello and welcome everyone to the day three of Adobe DITAWORLD. Hope it has been great so far. So let me touch upon something which I talked about last year, human and machine, especially the artificial intelligence part of it. So this is probably the most important part of human body. This is the CPU. This is where all the computing, learning, and all the instructions, uh, everything happens here, and the entire body functions accordingly. So let's see this particular section of the brain where the auditory cortex are, and it helps us hear. So all the signals go to this particular part of the brain, and it helps us hear. And what the scientists did was on some of the animals, they experimented, they disconnected that particular part and added the optical nerve to this. And the same part of the brain started seeing. So instead of hearing, it started seeing. It's really fascinating. And why and they did all other experiments, right? Different kind of experiments. And what they were up to was, does the brain function uniformly or different part of the brain functions differently, right? And what the conclusion was that it functions uniformly. The learning of the brain happens uniformly, in all sections, in all parts. So how does it work? So at the kind of micro level, the brain has neurons, right? And it's like all interconnected. So signals from one neuron go to the other, and so on. Right? So the signal coming into the inputs to the neuron, they are called dendrites, and they come from other neuron. And neuron does computing, and after computing, it gives out the signal through axon to other neurons, and that is where the output happens. The scientists, especially the computer science one and the artificial intelligence scientists, so they looked at it and they said, okay, can we make use of this uh, for the artificial learning? Especially this was quite prevalent in 1980s and 90s, and the area of computer science which came up from this was neural network, right? The artificial intelligence area. And on the left hand side, if you see, those are like you can take them as dendrites, the signal coming in, and the red circles are the neurons, right? So they can be different layers of neurons. So the signals coming in, it goes to all the neurons. Neuron does computing, and then it passes on to another, and then we can say that toward the end, it has done the computing. It creates the output and then sends it out. For example, in a human body, it may send a signal to the leg to move, and so on. Right? Uh, the structure of the neuron need not be this way. You can have more number of neurons, and it can have a more layers also. That is called deep neural network. So if you go deeper, it is so to a great extent. If you have more number of neurons, it gives us a better result, but it doesn't scale proportionally that way. At some point of time, you have to weigh your ROI, because it becomes very computationally very costly. So whether it is justified or whether that kind of result we are getting or not. Right? So what can it do? Where can we make use of it, especially in the teccom world? Right. So fascinating thing is it can do something like this. So you have a word AM sites, and you minus marketing, and you add teccom to it. It'll give you AM guides. Wow. We know that computer can do only computing, it does maths, but can it do the same thing for words, and in a meaningful way? How can it do, right? So it seems very fascinating. Let's look at it just from a computing perspective, what the computer is. How can it do something like this? So this is a table, all the words which I used in last slide. So they are in that first row. So AM site, let's give it some properties. So is it a CMS? And between 1 and 0 and 1, 0 is like no and 1 is yes. Is it a CMS? Yes. Does it deal with experience? Can we associate that word with it? Yes. Data? No. Enterprise? Yes. Enterprise class solution. End to end? Yes. Similarly, marketing, is it a CMS? No. Is it related to experience? Yeah, you can say that because experience is quite important over there. Data, no. Some people can say yes, but just for simplicity's sake, I have put a zero. Enterprise, yeah, it is kind of argue that it is used in the enterprise world, but it's not enterprise solution, and so on, not in the same league as AEM site. So 0.02, end to end, maybe no. And similarly, I have put some numbers for TechCom, AEM guides, and PDF. Now let's represent these. On the left hand side, whatever you see, they are called features, right? So let's see in a different light. So if we represent instead of a number, a set of numbers, it's called a vector in a maths term. So AM sites is represented as 11011, and similarly marketing, techcom, and so on. I did the maths, minus, plus, and equal to. If you see, this comes very close to what AM guides is, that vector is, right? So that is how the maths was done. So this seems very simplistic, that once things are in this form, oh, of course you will get it. You can do any kind of maths and so on. Now, how do you get that left hand side, which the features are? So for any particular word, what is the set of features, right? That is the critical part and the most complex part. As a That is not humanly possible to go and give features to all the words, right? So that is where the neural network and computing come into the picture. So let's see how that works. And it should work on all languages. It should not become language specific. So I have given an example of three languages. It's English, Hindi, and Japanese. So how it works is you give a problem to solve to the computer, and then it will learn the properties. It will learn the features automatically as the byproduct, right? So the problem is at the bottom is mentioned is a fill in the blanks. So if you have two words given, what is the third word? So it's a fill in the blanks. We are asking computer to solve. How it will solve is it will take a corpus of three words each and then try to do all the computing and so on, and then try to guess, right? Here I've highlighted those three words. Is omitted in doing all this computing because they are considered as a stop word. It's all over the place, so those are ignored, right? So AM guides powerful probably is the answer which will come. So to solve it, this is the neural network which we had earlier. You give all the words as a feature to the computer to solve. So AEM word, how it is given is, let's say you have a corpus of 200 words, you give all 200 in a vector, but you set AEM as 1, rest all are 0. Similarly, you give guides, so that is 1, rest all are 0, and it does all those computing and so on. It has a result is also a 200 word matrix, uh, but it will have a different weight to different words. And so I'm not getting into the complexity of how the whole thing works. That is not the idea here. What the computer will do while doing solving this the problem is learn the features, right? So it will learn that for the word powerful, this is the vector. For word CMS, this is the vector. And what you see F1, F2, F3 is that is what the values are. Those are called weights in computer science world. Now, I put three neurons. It can have more neurons, so you will have a more number of features or properties, right? But it is not like endlessly you will benefit. So there is a pros and cons, that what is the right number of the neurons you should have and how deep you should have, because it can get very, very computationally intensive, right? Expensive. So this is how the computer will learn while solving the problem, but you don't know what it has learned, right? AEM guides I had put as the features as, let's say, end to end or experience. So those were the named features which was given. But here, computer has learned something. How does it learn? It based on the context which you gave and the problem you asked to solve, right? So that is the limitation how it learns, but it has learned something. And then it can do wonderful things. So it's called self learning. It can do something like this: speaking and spoke, writing and wrote. It will not know that it is a verb and tense, but it will know that they are related, right? Similarly, India and New Delhi, France and Paris, it will learn that they are related in a similar way, but it will not know that they are country or capital. Similarly, it will go and learn for any language. Hindi and Japanese I mentioned, but it can go and learn for any language all these relationship properties, features, and so on, and it can do wonderful things, right? So in the teccom space, what all things it can do? So for example, smart tagging, auto summarization, content reuse, autocomplete, related content, content personalization. There's some of the stuff I have mentioned, but it can do much more, whatever we want it to solve. So it's a very interesting area emerging. It has been kind of there for the last 10 years. It started in 1980s and 90s, but for 20, 25 years, it was dormant, right? It was not taking off, but last 10 years, it has taken off like anything, and it's everywhere. You do machine translation, you do a whole lot of things. It's all these things are used, right? So it's pretty fascinating, and hopefully we'll see more solutions around this in our products, and which will help our users better. With that, I am done. So wish you a very great day three. Enjoy. There are like very nice sessions lined up, and thank you.